wonderful to see and hear everybody on the panel as well today. I'm going to use up every second. That's a great point. Being able to assume a planetary imaginary is a rather recent phenomenon, I'd like to suggest. While imaginations of global spheres are long-standing, dating at least to Copernicus, the specific attributes of being able to see the entire planet as a unit, I would argue, is a Cold War product, and therefore deeply implicated not only in militarism, but also in the related production of big data visualization technologies. Today, I want to make this point by exploring one of the key forces behind the development of our current planetary vision, namely nuclear danger, and specifically the politics, science, and historical legacies of fallout. Fallout is a relatively recent term in the English language, designating an unexpected supplement to an event, a precipitation that is in motion, causing a kind of long-term and unexpected damage. It is the aftermath, the reverberation, the negative side effects. And we talk today about the fallout of the mortgage crisis, or of official action or inaction, or of drone strikes and preemptions across the fields of counterterrorism. Fallout comes after the event. It is the unacknowledged until lived crisis built into an infrastructure or program. Fallout is therefore understood primarily retrospectively, but lived in the future anterior, a form of history made visible in negative outcomes. And I think we live today in the age of global fallout, inheriting from the 20th century a vast range of problems linking ecologies with national security, with science and technology, and finance in an ongoing negative aftermath. Industrialism, militarism, and capitalism are each massive fallout-generating practices, producing today reverberating crises. Fallout, the noun, comes to us from the verb to fall out, which is from the 16th century on has designated a social grade or conflict. It's thus the fight that separates comrades, marking an end of shared purpose. Military personnel also fall out from being an intention, a marker of a return to individual activities after a collective review, a relaxing of the conditions of formal militarism. Fallout thus involves individual actions and lived consequences, a post-sociality lived in isolation from the collective action of society or the war machine. Fallout, the noun, as we've already heard today, I think, is, of course, an invention of the nuclear age, appearing in the English language soon after the atomic bombings of Hiroshima and Nagasaki. Formally, fallout refers to the radioactive debris put into the atmosphere by a nuclear explosion. Fallout thus links human actions, technological capabilities, atmospheres, and ecologies in a new configuration. Radioactive fallout is, of course, also made up of a wide range of possible nuclear elements: cesium, strontium, iodine, each operating with radically different half-lives. Fallout operates, therefore, on a wide range of temporal frames and is both an immediate threat to health, radiation illness, as well as a long-term threat, cancer, possible mutagenic effects. And what I'd like to do in the talk is I'm suggesting that we use fallout now both as a historical object of study, but also increasingly as a theoretical category that can help us think of a number of ongoing legacy projects. So let's consider for a second how the American public was first introduced to the concept. This is part of the Civil Defense Project in the mid-1950s. This was a brochure that was widely circulated in the United States to introduce Americans to a new kind of invisible threat, one that, of course, is atmospheric and that can strike your home or yourself just standing on the street. And as we continue through the brochure, we get also an image of clouds for the first time as a new kind of danger. Instead of bringing the rain that we depend on, clouds now are the source of a radioactive danger, and also we're informed that it's both invisible and potentially deadly. Fallout, in this moment, reveals a new kind of environmental flow that matters to health and safety, but it also requires a new form of everyday optics, one that repositions the Earth dweller now as that risk within the atmosphere, directly challenging the territorial visions of the national security state. It also begins to suggest that while risk is collective, it's also asymmetrical. Not everybody's going to be hit by clouds in the same way. So we have new distributions of everyday danger, but we also have the problem of invisibility structuring how to perceive and understand that danger. How many of our toxic industrial processes fall into this similar category of the unseen but cumulatively damaging or deadly? How many issues of toxicity today are simultaneously also issues of scale and perspective, not only of what to see, but of how to see? So fallout is now both a material effect and, I think, a critical theory term for development. In Cold War practice, fallout was initially constituted as the bomb's lesser form, allowing a strange and perverse splitting of the nuclear event itself into the expected and planned detonation and its atmospheric effects. A completely predictable aspect of any nuclear event, fallout was nonetheless officially coded as a side effect. Much like drug companies today split the desired from the undesired effect of a molecule, the political economy of the side effect here has huge consequences, installing bizarre metrics and significant misrecognitions throughout nuclear national security logics, allowing certain forms of destruction to be recognized while others are marginalized. For example, while potentially deadly on a mass scale and constituting a new kind of chemical biological weapon in one, fallout was cast as a lesser concern to developing the bomb during the early decades of the Cold War. Fallout was instead subject to mitigation schemes involving studies of wind patterns and efforts to target the fallout at unpopulated geographical regions. And we forget exactly how widespread this project of nuclear testing was. So here is a map just of above ground tests from 1925 to 1963. I don't know how legible it is, but it gives you a sense of the breadth, the scale, and the number of nations involved in testing in those first decades of the nuclear age. This is also a map, we could say, of nuclear colonization, about where testing happens and who's in control of the test and who lives nearby. And what I'd like us to read this slide as a project in turning the planet itself into an experimental theater for nuclear science. The nuclear complex remains a vast industrial enterprise, quickly striving for a kind of planetary reach, not only in terms of nuclear weapons systems and delivery systems, intercontinental missiles, submarines, bombers, and so on, but also the production complex itself, which requires a global uranium industry, a global series of test sites, and related military support systems. To this particular map, if we were to get a sense of its planetary scale, we'd also, of course, have to add Hiroshima and Nagasaki, as well as a half-century of underground nuclear tests. And we could think of each of these sites as a node in a global nuclear network of technologies, experiments, waste, and fallout, each radiating on distinct temporalities and distinct frequencies. Fallout, in the form of accidents, contamination, and waste, has always been retrospectively diagnostic, forcing attention to how connected humans, non-humans, and environments are. Radioactive fallout has also been used as a laboratory for studying ecological transport, as earth scientists use radioactive signatures, particularly of strontium and cesium, as a means of mapping weather patterns, food chains, and environmental complexity. So what emerged in relation to this growing infrastructure is also a new commitment to earth sciences that is equally important to the story. And the planet is emergent in these processes as fallout becomes the means of mapping flows of every kind, moving from local exposures to regional contamination to global distributions of risk. So by the mid-1950s, atmospheric scientists are looking at the major thermonuclear tests in the Pacifics as experimental lenses for studying the environment. So these iconic images were turned into an experimental lens, one that could empirically document with a new specificity tracked the clouds from those previous two images and presented them as planetary events, tracking fallout no longer connecting to national territories, but seeing the flow as something that was increasingly striving towards the planetary. These studies directly challenged the current national security concept of the time, which required nuclear weapons to secure national territories, and instead is an early moment in what Ulrich Beck once talked about as rich societies. That is, communities united not by territory, national identity, or language, but rather by environmental and health risks. And Peter Sloterdijk more recently has pointed out that this was part of a larger 20th century use of the environment itself as a weapon, a new kind of technology which does not attack the body directly, but rather renders the envelope of the environment, the atmosphere itself, as something that's uninhabitable. Via fallout studies, a new kind of planetary vision was emerging in the mid-20th century. The early Cold War produced a massive investment in air, ocean, geology, studies of the ice caps in outer space, as an effort to track and investigate every possible kind of nuclear event and effect, but also these projects involved in efforts to militarize nature. In every case, nuclear injury was the motivating logic as well as the experimental lens for producing a new kind of what we now call Earth system science. The emergent data sets from these 1950 studies, as Paul Edwards has documented, became a kind of infrastructural globalism, allowing a new portrait of planetary process to be possible and contributing to our current understanding of climate change in fundamental ways. By 1960, Majda and List are offering images like this of atmospheric fallout, increasingly pulling back their field of vision off planet to understand the global flow of nuclear effects. And this is from a 1960 collection edited by Fowler on fallout, in which a combination of earth scientists, biologists, and health professionals were all talking about exactly how radioactive fallout was transforming ecologies and living beings through not nuclear war, but the test programs themselves. Crucially about this moment, the earth sciences became a national security priority in this moment, as efforts to study the bomb's material effects connected a wide range of scientists to the Defense Department in a new way. This year is also, of course, the moment that produces tremendous activism around the world, anti-nuclear activism, emergent environmental movements, and peace movements, and it produced in 1963 what was the first nuclear weapons treaty and the first global environmental treaty, the Atmospheric Test Ban, which took nuclear testing underground. Okay, this one's going to play in the background a little while. The fallout dangers created many new research programs that continue to this day. The survivors of Hiroshima and Nagasaki, as well as of Marshall Islands testing, became long-term human research subjects. And the logic of the security state became quite paradoxical in the face of mounting evidence of potential genetic damage on a collective scale, not from nuclear war, but rather from test programs. It's important to recognize that while cast as experiments, these atmospheric tests were planetary environmental events with far-reaching consequences. From the point of view of atmospheric fallout, for instance, the continental United States, precisely the territory that was to be protected by and secured by nuclear defense, was rendered as a new kind of sacrifice zones, as citizens became remade via degrees of exposure from fallout. If I had a longer time on this talk, I'd walk you through all of the National Cancer Institute studies, which demonstrates the distribution of fallout within the continental United States, but it's also a global phenomenon. It's both collective and asymmetrical. It's not evenly shared, even though everybody has little piece. So since 1945, we've all become post-nuclear creatures, marked with the fallout of nuclear weapons science. Here, fallout becomes a new planetary strata, suggesting that the nuclear age is both a geological period and the era in which the planet itself becomes a specific object of scientific study. study. And it also enters into our collective understandings in new ways under the sign of nuclear danger. From this perspective, the Anthropocene, a term recently popularized by Paul Crutzen to mark the industrial impacts on planet Earth as a new geological period, might be precisely dated to July of 1945 and the establishment of a new planetary radioactive regime, one whose signature is still ever present, a biological marker that links organisms and ecologies to national security in the form of toxic trace elements. Today, the rising ocean levels, shifting weather patterns, intensifying storms are generating wide-ranging effects across food production, public health, and urban space. In the face of these problems, various schemes for geoengineering our way out of climate crisis have been proposed. Geoengineering assumes the complete knowability of Earth's systems, even as it confronts the unintended planetary consequences of human industry. Programs for massive carbon capture, underground and in the oceans, compete with imaginative chemical proposals to shift the atmosphere by injecting sulfur particles into the upper stratosphere or changing the composition of clouds to reflect back heat from the sun. Other proposals look to space to create a mechanical means of diffusing sunlight and cooling the planet. In all, these proposals consider re-engineering the oceans, air, forests, ice caps, and outer space to handle CO2 and heat differently in the hopes of cooling the planet. And what's attractive to many about these schemes is the idea of correcting an atmospheric imbalance, of tuning the atmosphere. For those versed in the history of the U.S. nuclear program, and I think our previous panels have already touched on a number of these themes, these projects sound eerily familiar, mirrored in the scientific efforts to understand nuclear effects on land, sea, air, and the upper atmosphere, as well as in outer space. Each of these experiments was a form of geoengineering in its own right, producing specific planetary optics tied to programmatic visions of new kinds of experimental power. The U.S. nuclear program constituted the planet as an experimental theater. Nuclear testing zones were matched by a wide range of emerging technologies that constitute our world today. The triad of bombers, missiles, and submarines was, of course, supported by a fantastic investment in the development of supercomputing, the global communication systems, satellite surveillance systems, and the vast range of aerospace technologies. Attached to each of these was a wide range of scientific inquiries, producing a global seismic monitoring system, a global air sampling system, earth science investments in the Arctic, the ocean, the atmosphere, and outer space, which cumulatively have helped produce the data infrastructure for understanding contemporary Earth systems. Nuclear science itself generated a new kind of planetary engineering, affecting the biosphere via fallout, the geology of nuclear detonations, and nuclear waste storage. Thus, the way we now see and understand human impacts on planet Earth has been deeply structured both by the investments in nuclear science and in the technologies supporting nuclear science. And we are experiencing the fallout of both. As Roger commented on the way in which protests also intervene in new development of new technologies today. Applying the lessons of the 20th century nuclear complex to contemporary geoengineering schemes, we might well interrogate how the past half-century of multidisciplinary work to create highly detailed visualizations of the planet also now installs a dangerous confidence in planetary knowledge itself, as increasingly high-resolution visualizations come to stand in for objectivity itself, allowing us to feel in control of what are still vastly complex and partially understood Earth systems. One aspect of contemporary geoengineering discourse, for example, focuses on how to build an atmosphere capable of supporting life on other planets. Mars is often the center of these imaginative efforts, but they are also often motivated by the idea that environmental damage on Earth, the end of fossil fuel, a destabilized climate, overpopulation, disease, and so on, will drive the necessity of interplanetary travel. The escape pod to Mars has a long history in science fiction. It is an imaginative project that is often quite entertaining and important to think with. But before we launch such an endeavor, conceptually or in practice, we might well interrogate the ecological and health impacts that the introduction of synthetic chemicals and other long-lived toxins into the biosphere over the past half-century. We're living today in the unintended aftermath of cumulative industrial projects, remaking bodies and atmospheres on a planetary scale. So what's playing on the screen right now is Isao Hashimoto's remarkable visualization of the nuclear age. And what you've been watching here is he's showing in chronological time the number of nuclear detonations, both underground and above ground, from 1945 to 1998. Hashimoto shows us the planetary logics of the bomb and allows us to reconsider the temporality of nuclear war itself. In the Cold War competition between the US and the Soviet Union, nuclear war was conceived as brutal and short. It was a matter of hours and minutes, as always-on alert weapon systems, still active today, made war possible, literally every second of the day. Thus, we've inherited an idea of nuclear war as extremely short and totalizing, the end of everything. But Hashimoto, quite brilliantly, reorients our point of view, showing that a nuclear war was fought in the 20th century. It started in 1945 with 3 explosions, 1 in New Mexico, 2 in Japan, and then it was fought in test sites around the world. Hashimoto's piece is elegantly devastating in showing the international commitment to the bomb, as well as its planetary impact. In doing so, I think he gives us access to a new temporal politics of environmental crisis, the long-term violence that takes place over decades, offering us a perspective on a global industry that, in the name of both energy and defense, has performed as radioactive geoengineering. From the point of view of environmental toxics, there is therefore no need to project geoengineering with a specific planetary optic into a distant future or require travel to other worlds. We can look closer to home for an example of a planetary atmospheric politics. There's been a long-term terraforming project conducted on planet Earth, one that is drawn from the cumulative effects of industry, militarism, and capitalism. That climate change, despite such imaginative industrial activity and scientific insight across the generations, was not planned or intended is precisely the point. Constituted as a side effect of the industrial age, it articulates the ongoing challenge to conceptualizing an ecological security not based on the split between the engineered event and its aftermath. It does, however, require many new planetary optics, as well as a politics of complexity that can assume a post-national security understanding of crisis. And it also makes the 21st century nothing less than the age of falling. I'll say this is about a 14-minute piece, and I can give anybody the link to it. It has a soundtrack as well.
Okay, well, I'd like the students then to sit if you like, perhaps, and we'll have a discussion for around 10 minutes.
Also a broader question to Ray. Maybe I didn't understand it correctly in your paper when you said one issue that you stumbled across was that the knowledge of the nuclear was conflated with intelligence. So nuclear information and knowledge and intelligence were somehow linked in a positive way. Did I understand that right? In the way of communicating and conveying what this technology could do for present and also future generations in time forward. What's problematic about this? I would like to ask again how this really also in a much broader sense informs what this discussion has been about, like this conflation, intelligence and sort of knowledge or information or science.
Okay, I was alluding to describing in some sense that Sagan and his colleagues and others that worked on these messages, both the interstellar one and the quick marker systems, assume that evolution is applicable on a global scale to many levels of matter and even at the level of social groups and intelligence as well. So I think it's problematic in as much as it's a teleological argument. It's an argument about progress, the march of progress. And there's little by way of agency which is incorporated in that kind of narrative. And it's seen as an equivalence. It's all folded into a notion of cosmic evolution. And nuclear technology is seen as indicative of intelligence. It goes unquestioned that to arrive at a point in which a culture can command, design, build and manage a nuclear technology, it reaches a threshold point, as Rob alluded to as well, and specified, and that once past that, it continues to unfold, that the nuclear technology constitutes a necessary passage, not only for what happens on Earth, but for all cultures. I think that's deeply
For
problematic.
any civilization that wants to call itself so and wants to be advanced, it's sort of the rational per se in a way. So seems to be the equalization of the rational and advanced with anything that's nuclear.
Yes. So nuclear is seen as a necessary stepping point along not only the development of science, but the development of intelligence, the development of communicability, and of survival. I think it is deeply problematic to have the notion of survival tied to any technology. I think that's an overstatement on the part of the advocates, or even, dare I say, the critics. Any other questions?
Roger, I wish you would have more time to elaborate on these analytical categories which you mentioned on the slide, and I would add one, which is the international dimension. Just know from the German case that in the late 60s and early 70s, national laboratories, nuclear laboratories, all developed these nuclear reactor for space application. They wish to have, say, a mission for their future because there was nothing more on the civil market, so they wanted, also the classical market, they wanted to diversify, to kind of strategy to survive. So my question to you would be, well, did NASA or US-American agencies in the post-Apollo period use, say, that their European collaborators, their partners, also to pool resources and to get credibility, or in what sense was there kind of strategy to collaborate, or was there the proliferation problem which in that sense hindered collaboration here that the Department of Defense may have intervened?
Yeah, no, there was clearly there was collaboration in terms of space missions all the time. I haven't explored, this is something I should probably look into, what relationship international collaborators might have had in the context of these nuclear power systems that were going to power spacecraft. Famously, the Huygens probe was a part of Cassini. The interfaces were pretty clean there in the sense that there was not a lot of involvement of European scientists and engineers on Cassini and vice versa. But did anybody raise anywhere the fact that we got a nuke on this thing? I don't know the answer to that, but at least it didn't stop it. And my suspicion is that the engineers and scientists associated with making this program move were not troubled by that in the same way that American scientists and engineers were not troubled by that. But that's a guess, and I may be wrong.
Can I follow up on that? Sure. Because there is an interesting article that's not the satellite version, but the nuclear rocket and the nuclear plane,
absolutely,
which were huge research projects for decades, right? And then stopped precisely under the kind of threat. So do you have a sense of how that line gets drawn, or even a particular era in which it gets drawn finally between things that would operate on the planet versus outer space?
Yeah. Now there's clearly a a line of demarcation on that. The nuclear aircraft was, well, a bad idea on so many levels. I don't even know where to begin. And the fact that it got more legs than it probably should have in the United States is an interesting dynamic in the military-industrial complex. The nuclear rocket, all through the 1960s, was a major research program for NASA. Yet, I know more about that. From 1964, 65, and there was serious misgivings inside the agency about this, and the fear that they could be endangering literally millions of people through this process. And that program was killed in 1970, never to be revived, although in the early 2000s, Sean O'Keefe, the NASA administrator, tried to revive a nuclear rocket program for in-space propulsion only. Chemical propulsion to orbit, whereupon they would fire up a reactor to go to Mars in 3 months or something. And but that got no legs either because of the public misgivings, but even more than that, there were serious misgivings inside the governmental administration.
Yeah, great panel. Sorry, my voice is a bit soft. Really enjoyed all the papers. But to Joe, I'm sure you've thought of these things, maybe in a longer form piece, but in terms of planetary engineering, the Ploughshares program is the most obvious. And indeed, in terms of nuclear colonialism, its outreach was international. The kind of cobalt bomb scare in the early 50s, manifesting on the beach, and the way that kind of played out, again, is the kind of major concern about fallout. Speaking of Carl Sagan, the idea of nuclear winter as a result of planetary impact, sending rockets into Jupiter, kind of see what would happen after a cometary impact in Jupiter. So there's a whole range of tropes, I would argue, that are already, Krakatoa. So there's a kind of huge thing that you've got going on there, but I'm sure you're aware of that.
Yeah, no, I agree entirely. It's a broader piece that discusses it well. I guess the part that I'd like to put forward here is the idea of what does it mean to understand the complexity of the biosphere, the complexity of planetary flows, but only through tracking actual injuries occurring. And that there's something about that we haven't yet kind of constituted as the way in which we understand planetary effects. But this is something that I think all of the papers today, in their theorizing of the nuclear age as something quite distinct, are getting this idea that injury, nuclearization, and all of our narratives of progress in technology are deeply implicated today. And I think we're at a kind of threshold moment where that needs to be deeply unpacked and understood at a level.
And just quickly on the impact of injury, I mean, the whole Cold War clandestine body snatching programs throughout the world, again, is a kind of another form of nuclear colonialism where body parts and all kinds of things were being used to create that data.
Yeah, I'm interested in some of your players, especially in the first paper, as described, wondering if they could be described, and it should be described, what Roger had described as techno-scientific entrepreneurs. The people like Clark and Sagan. Was the promoters of space travel, particularly, those are the ones I'm interested in, have you made an effort to determine whether the bomb was the motivation for space travel or the rationalization for space travel?
I think it was a rationalisation, definitely, because the space travel movement had taken off in the 20s and 30s, and the arguments for the necessary stage of human progress were there. But it gets mixed up after 1945 with the need for an alternative to a future in which there is a nuclear war. And the thing that I didn't really talk about very much was that there's a strong argument that once humanity's got a base outside the Earth, it then becomes invulnerable to extinction. And quite recently, Sir Martin Rees was saying much the same thing, a few years ago in the book.
Yeah, but they can also bomb the Earth. I mean, that certainly was an early motivation. My interest, though, from a historical standpoint, is to be able to, if you have a mechanism, if you have a way of sorting out motivation and rationalization for people who promote very large techno-enthusiastic projects, whether they be space travel or large telescopes or anything like that. It's something that, you know, we all come down one side or the other on, but I would love to see real solid work of people who have in analyzing what the motivations truly are, if you follow what I'm saying.
Yes, I think it is a rationalisation rather than a motivation. My method would be close reading of a lot of the writings of particular people. In my case, I had it with a little bit at Clark, others look at Sagan. And you can see them connected together. But I think the astrofuturists, the space propagandists, are happy to take anything that makes the case for space. They occasionally actually say, well, there's all sorts of arguments that will do as well, but basically we know that space is the future. We feel it. We love space. You know, we want to do this. Anything that helps us get there is good. And they've got quite a shrewd sense that if you can say, well, this is better than nuclear war, this is better than blowing ourselves up, this is the alternative, then that helps to make the case. So there is, in a sense, in which public support for progress is related to public fear of the atomic bomb. It's not necessarily the motivation for everybody who explores it.
Okay, thanks.
I'm from Japan. I have kind of comment to do. Why we did the Fukushima failure? Because of the word that is peaceful use of energy was so much attractive after World War II. We had a really serious damage from Hiroshima and Nagasaki atomic bomb disrupted people and cities. So peaceful word, some kind of useful for Japanese people to continue doing some kind of atomic power to produce electricity. So that was some kind of historical fact, I think. So Japan shouldn't take that technology to produce atomic power to use electricity. I'm physics background historian. I feel so bad to feel that I shouldn't move against further this introduction of nuclear power to produce electricity, because Japan is such a earthquake country. This is different from other. Some areas are still Turkey or elsewhere very much the same in the sense of earthquake country. So we shouldn't have that. So second speaker, interesting symbol of nuclear waste. That finally we had that abstract, very nice. But we shouldn't have some kind of bone, X, and human voice, not human face, having trouble, looks like that. That symbol would be help at least to Japan, I think. Thank you for your attention.
I think, unless anyone wants to respond, I think we're kind of 10 minutes over time as well, so I think we're going to be having a break and then we're going to be coming back for part 2, Space at Work, Space Programs and the Environment, at 4 o'clock, and I guess there's questions downstairs.